Hey guys, I have one more for you right now. This is going to deal with ratios, the ratios between two events. And a ratio is really just comparing two numbers. So let's say that we are looking at a cell and they tell us that the surface area of that cell is 64 and the volume of that cell is 96. Let's say, I don't know, it'd probably be some kind of tiny unit. And they want to know what the ratio is. Well, I mean, all you simply would say would be 64 to 96, okay? However, a lot of times they don't want that. They want it reduced. And so there's two different ways we can reduce this. We can reduce it first by finding the greatest common multiple, which is a term that I learned, I think, in elementary school math. I don't even know if they use it anymore. Somewhere along the way, maybe you've heard it or learned it. But it is simply the largest number that divides into both of these. And so the largest number that will divide into both of these is 32. And so we can reduce our formula, our ratio, down from 64 to 96 down to a 2 to 3 ratio. So what that means is for every 2 units of surface area, there are 3 units of volume. Sometimes they may want you to take it all the way down to where one of the numbers is 1. And so in that case, you would divide, you could divide each side by 64. That would give you a 1 to 1.5 ratio. Or you could do it the other way and divide both sides by 96, which would give you a 1 on that side. And I think that would be 67. So all of these ratios are equivalent, okay? All of these ratios are saying the same thing. And so it really just depends. They may just want this simply the two numbers compared side by side. When do we use this? Well, the main time that we use this is with surface area to volume in cells. And so generally what they will do is they will give us 3 different cells. So they'll give us cell A, which is 64 to 96. Cell B maybe is 12 to 60. And cell C is maybe 15 units to 12. Okay, so whatever it is, picometers or whatever you're using to measure, micrometers, whatever. And what you want to do is you want to be able to compare cells A, B, and C. Well, we can't really compare it with all these different numbers. And so what we will do, cells tend to be healthier when they have the most surface area to the least volume. So what we need to do is we need to get all of them to 1 on one side. Either all of their surface areas to 1 or all of their volumes to 1. And it doesn't really matter which way you do. If you take all of the surface areas to 1, then you're going to find the one with the least volume. And if you take all of the volumes to 1, you'll find the one with the biggest surface area. So I'm going to do it that way. And the way that you would do this, so this is surface area on the left, volume on the right, is I'm going to divide all of these by their volumes. So whatever the volume is, I'm going to divide both sides by that number. Okay, that is going to take my volume down to 1 because 96 divided by 96 is 1. And then I already know from doing it over here that that is going to be 0.67. Okay, so all I did was divided 64 divided by 26. It gave me 0.666 repeating or whatever, so that's 0.67. Here, 60 divided by 60 is 1. 12 divided by 60, I believe, is 0.2. Calculator tells me yes, I'm right. And then this one, 12 divided by 12 is 1. 15 divided by 12, I think that's going to be 0.1 or 1.25. And that is what it says, 1.25. Okay. So now all of our volumes are equal as far as our ratio is concerned, and we can look for the one that has the biggest surface area. So obviously of these 3 numbers, this is the biggest. So cell number C, cell letter C, would be the healthiest cell because it has the most surface area to volume. So that's how you form a ratio or how you calculate or reduce a ratio, and also an example of where you would use this in AP Bio. I hope that helps. If you have more questions, let me know and we'll go over it again.